Okay, so um, I guess I'm back with Devlogs. It's been a while since I updated the channel, and I was hoping to sort of get back sometime last year, but a lot of things came up. Work started to get a bit busy, a lot of projects here and there. So I really didn't find the time to do programming videos. So uh, so one of my, I guess, New Year's resolution this 2019 is to sort of, as much as possible, try to commit some time to make this to make these videos. I found it sort of enriching to sort of do something outside of work, you know, because sometimes work can get redundant, especially since we do a lot of web applications, database stuff. So uh, it tends to get boring. And if you're into programming, well, at least most programmers sort of want to do new things, right? Sort of want to divert their attentions to either pet projects or something that interests them. So back then when I started the channel, I created some videos on how to build a neural network from scratch. I think this was using C++. And it was quite difficult, right? You had to deal with a lot of low-level stuff. And it was good to learn the inner workings of how a neural network works. But I guess it wasn't that good in terms of sort of learning the process of development itself, right? Because you have to deal with a lot of technicalities with C++, although it's still one of my favorite programming languages. But sort of you want to create like real practical applications at a short period of time. There are a lot of other available tools out there um, that you might want to customize to fit your own needs. And sort of this is what this particular series is about. So I plan to do the neural network video again, but I have a lot of assumptions at this point. One assumption is I won't go through the concept of how a neural network works. I'll probably go through some of its details, but there are a lot of videos, a lot of tutorials on the web that already explain this. Instead, I want to focus on how to sort of take these concepts and make it, or probably create a more practical application for this, based on these concepts, right? So what I mean by this is that there are a lot of tutorials in the web that teaches you like what a neural network is, but there are very few videos on how to actually use a neural network in practice. One such example is that there are a lot of videos like, say, here's how you build a neural network using Python, for example, or C++ or some other language. But then you probably use some very high abstracted infrastructure like the Python, the Jupyter Notebook, for example. And if you wanted to sort of use it in a different data set to learn or to create a model for a different data set, you'd have to change a lot of code, which sort of defeats the purpose of how we would use software. Right? We want software to be portable. We want software to sort of be used on a day-to-day basis. So given that particular notion, I sort of wanted to create a practical neural network, so to speak, that both teaches you how to use a neural network and makes it portable enough so you can extend it to your own needs. Right? And for this particular series, we'll be taking a look at the Keras library. I've been using it sometime last year for some projects, but since then it's actually quite good. It lets you do a lot of things faster, leaves the lower details to the library so you can focus on the application itself. Right. So I want to sort of merge the Keras library with I guess the coupling of the different things that a practical neural network application should have. So I have actually initially wanted to start with the Wikipedia, but just so we can get the actual programming part started, I want to sort of start with a high-level overview of what I want to do, starting off with how a neural network works. So again, you have this input. Okay, so the input again will refer to your data, right? Or the representation of your data, the features that you want to learn for a particular data set. So the assumption here is that your input layer will always be fixed in terms of the number of dimensionalities, dimensionalities rather, but if you want to learn a different data set, you'll have to change this, right? So For example, in the iris dataset, popular dataset, if you sort of pull that up. Okay, so it's a okay, so the iris dataset is a very popular sort of beginners dataset in terms of you know, starting out with data science. It has 5 attributes, so petal length, petal width, sepal length, sepal width, and species, right? So there are other variations of this dataset, but basically this would be your feature vector, right? So this would be your input. So input 1, x1, x2, x3, x4, and x5. So your neural network will have a size, an input size of 5, and then the rest of the architecture is sort of the hidden layers until you get to an output layer which will serve as your classification. So that's how basically how a multi-layer perceptron neural network works. Now, if you wanted to learn a different data set, let's say you want to learn something that you picked up from online or for your own personal data set, you have to change the code to adjust the model, your new model, right, to adjust to the size of your input layer. Plus, if you want to play around with your hidden layer, your latent variables, then you'll have to change a lot of code as well, right? So basically, what I'm trying to say again is I want to create an application based on Keras, Python, right? That sort of is more flexible, that all we have to do is to change a configuration file and pass our data set to it, and it will train the model, so to speak. I'm not sure how far I can get with this, but I actually tried to do this back then. I have the repository up in GitHub, but it's been a long while since I touched it. So I sort of want to review. I took it as an opportunity to sort of review Python programming, because I can't remember the last time I touched Python. I'm not really a Python developer, so to speak. But let's see how far we'll go, and hopefully I'll probably chop this video up into multiple episodes, right? Or starting off with creating my workspace. So maybe I'll name this KPYNN or KMLP, short for Keras Multilayer Perceptron, right? Okay, so I'll create that project first. Okay, and recently I started to play around with Anaconda, that sort of creates a excuse me, actually still sick with cough from the New Year's. Right, so where was I? Right, so I started playing around with Anaconda that sort of creates a virtual environment for Python, or at least that's the way I understand it, so that you can have applications running in a specific environment with its own set of Python libraries, right? I believe I created a devlogs sort of environment from Anaconda, right? Right. So again, the objective is to create a portable application using Keras, Python, that implements a multi-layer perceptron network that is flexible enough for your own practical use or for other data sets. Now, I'll start off by, not by coding, but rather defining what I want to do, right? So I'll start off with a README file, and then sort of the README file will describe how I want the application to work, right? So again, I have this code up already on GitHub, but I sort of want to modify it because I've seen some setbacks, and again, I wanted to take this opportunity to actually to actually do that, so we can sort of go through the process of software development. I'm ranting on. So maybe I'll just name the main program mlp.py, and I sort of want to run it by saying mlp.py. Probably I have an option mode that can either be something like train or predict, right? And then what I want is I want a flag that will point to the config file. Right, so this one will be something like a path to config file, and the config file will just be a JSON object that will have all our parameters, and the application will basically excuse me, will basically read through that that configuration file. So again, I'm still sick with a cough, but it's getting better. Okay, config file, and the last thing I want to do is that I guess the model, so whether you're in training or in your predicting, you'll have some sort of model, right? The model will explain, like, I don't think we need an equals here, right? So the model will tell Python, or will tell the program, in the case of training, what file to save the model in. In the case of prediction, what file to read the model of, right? So I want the application to sort of have that model flag with it. And with this, it will be the path to the model file. Okay, so maybe I can start with something simple like that. Okay, so that's the README file. Right, so going back to this diagram, if I want to make the neural network portable, I want to have the layers as part of the configuration. Because if we look like the multi-layer perceptron network, sort of a feed-forward neural network, right? That is just composed of layers, and layers have neurons in them, or rather the nodes in them, right? If you're in the leftmost layer, you're in the input layer. If you're in the rightmost layer, then you're in the output layer. So we can sort of implement this as a configuration in our JSON by saying something like, okay, if I had a JSON file here, the configuration might look something like this. Okay? I have a key here called layers. And these layers will represent an array of layers. Right? Each layer will be an object that will, okay, so for example, if I wanted to implement this, this one would probably look something like this. Right? I have 3 objects represented by these curly braces, and each of these objects represents the layers inside my layers key inside my configuration object. Okay? And just if we were to implement this, this would probably have something like size 4. For the hidden layer, this would be 1, 2, 3, 4, 5, size 5. And for the output layer, just one node or one neuron, in this case size 1. Okay, so you get the idea of having that portable configuration that you would want to pass in your application, and pass that to your Keras model, right? Okay, so maybe that's a good start. Okay, so the first thing I'll do, probably I'll create that mlp.py file, right? So it's more consistent with the README file, right? Now, let me just open up Tmux for this project. Okay, just check which Python I'm on. I think I have to activate again. Okay, so it's the first time I'm using Conda in an actual software project. So I think it's Conda activate devlogs, right? All right. Okay, so I have the Conda environment activated there. And the reason why I want this is I want to have multiple windows so that I can sort of reference README here. Okay. Right. So even before going to the actual neural network part, maybe it's a good point to start. How do we implement this, right? How do we get the flag mode? How do we get config? And how do we get model? And then from config, we can probably print out like the different configurations that we put in our JSON file, right? Okay. So I've been playing around, thinking what's the best way to implement options in Python. Okay, and I think the Python developers use the this thing called argparse. Okay, so it's something. Okay, for now I'll just print out some headers just so we have something working, right? So Keras MLP trainer or app. Or whatever, right? It's just a header anyway. And right, I'll just leave it at that. And then I want to have some sort of argument parser. Okay. So if I want to implement this, Okay, I forgot how to implement string arguments. I mean, the code is really old, so maybe I'll shortcut this to M for mode, C for config, and O for output. I know there's a way to sort of use the word version for the flags in the command line, but I'm using an old code base, so I can't remember. Actually, probably look it up, right? So arg parser or arg parse in Python 3. Let's look up a tutorial on how to actually do it. Okay, so I want something like this, right? Verbosity will be the word configuration, right? Okay, so we won't cheat. This is our spec, so we should comply to our specification. Okay, so we do something like this, right? Of course, we import arg parse first. I guess here on top, import arg parse. Again, I'm not really a seasoned Python developer, so this might take a while. Okay, so we have parser, so we get it from parse, something like that. Put it here, right. Probably under the comment. Okay, so apparently we can do something like parser that add argument. And then let's start with the first one, right? Mode. Help. Mode. Mode of running or something. So this can either be train or predict, right? Okay, let's try to solve this first. I'm going to capture the value for mode and sort of print it out, right? Okay. I think this is the one I need. Oh, okay. So apparently my code is up to date with this thing. I can actually do something like M. Okay, so the first argument is your flag in its sort of letter form, like with just a single dash. So, excuse me. So dash M or dash dash M for, or dash dash mode for mode, and you can actually provide this to be required, right? You can say that this one is required by saying required equals true, and the help part will be the mode of running, which can either be train or predict. Okay, so if you actually want to, excuse me, if you sort of want to get it, we say args, parse ap that, let's see, parse args. Sorry, I think we're using parser. The old code base I used AP for argument parser. In this case, we're using parser, so we'll use that. Parse args. And I think this will create some sort of a hash, right? Or a dictionary or hash object that will represent the different arguments that we pass to it. So for example, I can have some sort of variable called mode. Okay? And if I want to get the value for mode, I can say something like this, right? The actual option that we pass to the command line becomes a key in the args part. Okay, so just to test this, you can say that the mode will be, excuse me. Okay, so I keep forgetting how we actually use print strings in Python. So apparently we do something like this, right? %s, similar to printf. And then we have a % here, and then the actual variable that we want to sort of output, right? So for example, in this case, the variable would excuse me, the variable would be mode. Right. Okay. The variable would be mode. Let's see if this works. Mode train. Okay, and then mode predict. Okay, so it's reading it properly. So I guess that works. So we'll go ahead and extend this. Right, we'll go ahead and extend this for our next option, which is the configuration to the configuration file, the path to the configuration file given by the option config. Right, so it's the same process. So we have parser that add argument. You can call this C or config. We'll always have the user pass it. Path to the configuration, the JSON configuration file, right? And then we'll start with a variable called config. Okay, to print it out, we'll say config file is located here, and for config, right? So for example, if you try to run this, so why did I close it? Okay, you can say something like Python. Oh, I don't think we're. Every time I open up a new window in Tmux, I don't think we're using the conda. Okay, so maybe I'll do something like conda activate devlogs. Okay, to indicate that we're actually using it. The Python environment in a named devlogs, right? Okay, so let's say Python mlp.py. Now, if you don't specify anything, it actually reads the configuration file, right? For this one, it actually reads this one. So if you do Python --help, oh, sorry, right there. So it actually reads the options that we just put in. And whatever text we put here becomes of some sort of help menu, right, for our command line application, which is a very useful in creating command line applications. Okay, so we have our config file right there. So let's go ahead and test this out. So we say mode train, and then config current directory config.json. So it's reading off from config.json. Okay. So now that that's working, the next thing we'll do is actually read off the configuration file. At this point, I'll just sort of copy what I did before. Oh, okay, I remember. Now, to actually read the configuration file, the actual reading, I sort of delegated it to a different to a component, right? So again, you want this program to be portable. I don't want everything sort of what do you call this? Sort of stuck or inserted in a single Python file. I want it to be as object-oriented as possible as what I do in most part of my work. So I want to apply whatever I do in work and try to sort of insert it here in for this particular project. So when I tried to do this the first time, apparently Python behaves quite differently, right? I can't just create a directory and make it a namespace for the application. I sort of have to do some work around it, which I found weird because, for example, in Ruby, it's actually easy to include relative paths of different Ruby files and make that as your separate component for your application. But in Python, you have to do something quite different. So, for example, I can create a directory here called classes, which I'll store my Multilayer Perceptron class. So in this case, mlp.py. Okay, and I try to do some sort of object-oriented. I try to study how Python does object-oriented programming. It's really quite different from things, right? Now, before I actually write the class, in order for me to read this file, actually, I think the best way will be to show you instead of actually, jumping from one topic to another. So Okay, so I'll create the class first. So in Python, classes are created using the class keyword. You'll give your class a class name, so Multilayer Perceptron, and use the start of the colon to indicate the start of the body of the class, I guess. And the constructor for a Python class is given by the init function. And apparently in object-oriented Python, the first argument to any function, any member function of your class will be self. Reference to this, right? If you're using Java, this in Ruby is also self. Okay, so whenever I construct a multi-layer perceptron class, I want to pass the config file, right? Which Python reads off of. Okay. Now, to actually read the file, you have this nice little snippet here. Okay, so accept the config file, and we represent it as variable f, right? And we want an instance variable, or a member of this class called config, which we load using Python's JSON library. Right? In this case, we say import JSON. Okay, so the idea here is once we get the config file from the command line argument, okay, we pass it to this class, which reads off of it and instantiates the configuration as a JSON object inside our class. So to do that, we have to import this class, right? So I was looking for something like import, since classes is relative to my current working directory. I wanted something like import classes / MLP, for example. Because apparently in Python it doesn't work that way. You have to do something like from classes, which is the name of your directory relative to where you're running your main program, .mlp, which is now your actual Python name, Python class rather. You import the name of the class, which in our case is Multilayer Perceptron. Right? Okay, hang on. I have to move my car, so I have to pause it for a while and come back in a few minutes. All right. Sorry about that. So the bell earlier was actually an indication that the car behind me, where I'm parked, right, has to go out. So I had to move my car and and sort of take his place, right? So okay, so I had to stop there, and my cough's really terrible. I'm still coughing a lot, so I have this water jug to sort of relax it a bit. All right, that's where we're. Okay, so we implemented the multilayer perceptron class, and we want to import it in our main application. Excuse me again. Right. So the way we do it in Python is that we import the class name, right? But we say from classes, which is the name of our directory here in this structure, .mlp. So MLP is the name of our file, right? Now, when I started using this style in importing external classes, it didn't work as is. So I tried to run this again. Well, actually, it worked, right? That's weird. I guess it's a Python 3 thing, but I had to do something like add init.py, right, for it to actually work. I think in Python 2 it was a requirement. So I guess in Python 3 it's no longer needed, right? Well, we'll see. We'll probably run it into it later. Okay, so we have our multilayer perceptron class here, and let's see if it works, right? I'll just sort of instantiate an MLP object using the constructor of multilayer perceptron. And we do that in Python by first declaring a variable. So let's say, in this case, MLP equals multilayer perceptron you actually don't have a new keyword. We just use the name of the class as a constructor, and we pass the config file, right? Okay, so config here refers to the file that was passed from the command line, gets turned into this argument, and we have an instance variable called config from our class. Okay, let's try to run this. Okay, so no error so far. Okay, so once we have the configuration file there, we can then start to sort of read off of it, right? So this one becomes a JSON object. Okay, and the way we set it up is that we sort of want each of the layers objects. So let me just refer to that config file again. Okay, we want to again refer to each of these objects as a representation of the layers, right, of our neural network. Okay, so the size attribute here refers to how many neurons can be found in that particular layer. Now again, since we're using Keras, right, Keras sort of has this abstraction on how a layer is defined. Okay, so we say import Keras, or rather from Keras, import layers. Okay, so the layers component of the Keras library will allow it to create different types of layers, right? The most basic one is this thing called a dense layer, which represents a vector of neurons, or a vector of values for your neural network. Okay. So the idea here is that we want to loop through our layers array and create sort of a layer for our model, right? Each of this will be represented essentially by a Keras layer. Okay. But before that, we have to first instantiate our actual model, right? Because the one thing I don't like about Python is that it's really hard to tell where one thing ends, because everything is like tab delimited, but right, you'll get used to it if you're new to programming in Python. Okay. And usually I have this habit of having equal tabbing for my equal sign, which tends to go too far away. Okay, so we have ML, or we have to import excuse me, models. Okay, so models is the component in the Keras library that represents a type of model, right? A type of neural network representation. Okay. One such model is called the sequential model, right? A typical feed-forward network from left to right. So you say models sequential. Okay, so to create a sequential model and represent it as an instance variable called MLP. Okay. Now we actually loop through that particular configuration file. So we say for I, I'll call this layer config, right? So we have two variables looping through enumerate the configuration for layers. Okay. So again, layers is an array of objects represented by our config variable key layers. We pass that array, so this is essentially an array of objects, right? We pass it to an enumerate function in Python, which we can loop through it. I will represent the index, and layer config will represent each element in that particular array, which in this case again is an array of configurations for each layer. Now, just to connect it back to the drawing, so each layer here, okay, we want to represent it as a Keras layer. However, our input layer is rather special, right? Our input layer will not be activated in neural network speak, right? So we know that we're in the input layer if our I, if I is equal to 0, then we know we're in our input layer. Else, we're in all other layers, right? So what happens if I is 0? Well, if I is 0, we tell our model, we add a dense model to our MLP, our Keras model, represented by self.mlp, an instance variable inside our multilayer perceptron class. Because again, we want this software to be modular so we can extend it later on for probably more practical uses. Okay, so we say self.mlp.add, and we create a new dense layer, right? So we add a new dense layer inside our model. Now, since we're in the input layer, right, the arguments for dense will be something like the size, the activation, and the input dimension. Now, input dim is an argument for the dense class. Let's look up the documentation. Excuse me. Okay, so right, so every time we create a new dense layer, we first pass the size of that layer, right? And since in our configuration we have size right here, okay, represented by layer config, we can say layer config size. Okay, so we make the size, I guess, portable in this case, right? I think I'm missing something here. I can't remember if this will work as this, right? But yeah, we'll try to do it this way. So layer config size, our activation will be something like, so layer, Keras has a wide variety of activation functions, right? So we say activation, okay, some activation function. You can have your own custom activation function, but in this case, we'll use some built-in activation functions provided in Keras. Okay, so we look at the documentation again. Okay, so you can have something like activation tan-h, or the name of the activation tan-h. Okay, and as you can see in Keras, your activation can be represented by a string, which is very convenient for us because now we can actually configure our activation to have to be part of our JSON file, right? So we can say something like the activation for this layer will be tan-h, for example, but this one will use something different and this one will use something different, right? For the output layer, you probably would want something like sigmoid, right? And for the hidden layers, you probably also want sigmoid or probably something like relu, right? Okay. Now, the main difference is that, well, the input layer doesn't really need an activation, right? Because it's the input layer. Right. So just put relu for that, relu for the hidden layer, and then sigmoid for the output layer, right? Okay, so we say activation, layer config, activation. Okay, so we read off of that. Now, the difference between the input layer and all other layers is that this one will have an argument called input dim, which is the number of an integer value representing the number of dimension, the dimensionality as an input for this particular layer. Okay, so we say your input dim will be the input size, right? So in this case 4. But again, we want it to be configurable, so we have another parameter in our configuration file called input dim. Okay, and then we say 4. Okay, this way, we can just refer to our config file and say input dim, or config on project and just say input dim. Oh, okay, I missed something. Okay, so actually this, okay, rather these layers, rather, the first element of your layers function, or layers function, rather, your layers array is not the input layer. Okay. I just remembered right now. So these layers actually represent the hidden layers. Okay, that's why your first hidden layer will have that input dim argument. Okay, because your input layer doesn't need an activation. It's just a representation of your feature vector with some dimensionality measurement that you pass to the first hidden layer, of your neural network, right? So let's look for another. Okay, let's just, if we were to implement this diagram, then our configuration file should actually be something like this, right? The first layer is your first hidden layer. The second layer, well, will now be your activation function, okay? And we want to know that we're in the first hidden layer by referencing if the index I is equal to 0, because we want this hidden layer to actually accept some input by saying input dim self.config input dim, which will be our configuration here in this config object, again represented by self.config. For all other layers, we'll say self.mlp.add layers.dense layer config size. So it's the same thing, right? The only difference is you don't have that input dimensionality, right? Okay, so if it's the first hidden layer, we have input dim to refer to like what's the expected input for this hidden layer. We activate it using some activation string that's read by Keras, right? So relu right here, and then sigmoid for the output activation. Okay, so this sort of sets up the model, right? This sort of sets up the model. Okay, so I guess this should be 5. Okay, so again 4, 5, 1. Input size 4. First hidden layer 5, and then our output layer or last layer 1. Okay, so this sets up our multi-layer perceptron represented by a Keras sequential model. Okay, now we can compile this model, okay, because we just set it up. We just built that sort of neural network using Keras calls, right? And usually in Keras you do something like compile. Okay, now we could always do it in our constructor and say something like self.mlp dot compile. Excuse me again. Okay, but this one is sort of sorry. This one is this one is not as portable as I want it to be, right? So I sort of create another function within the class called compile. Okay. Again, we have to add self as the first argument of the function. Now, compile will have certain arguments. At least the compile function in Keras will have certain arguments, such as, for example, including the accuracy, right? So we can actually pass it and say as an argument called metrics, and the default value will be accuracy. Okay. Excuse me. All right. Default value of accuracy. Now, the compile function of, well, at least in Keras, right? If you take a look at the documentation, compile Keras, compile. Okay. So when we call the compile function from Keras from a given model, we pass other parameters such as the optimizer, okay, how the training will actually work, right? So so you have, of course, you have the backpropagation algorithm, excuse me, and you have other options as well available in Keras. We also have the loss function, and as you can see, they're also represented by a bunch of strings, right? So we can actually also include that in our configuration and say that our optimizer will be SGD, for example, right? Excuse me. Let's look it up. Optimizer SGD Keras. Okay, so an optimizer is one of the two arguments required for compiling Keras model. So we have SGD and others as well. You can sort of read through the Keras documentation. So you have SGD, you have RMS prop, you have Adam, and as well as other slew of arguments, right? Now, again, we want to sort of create a wrapper around this. We want to make it portable, right? So we can just change the configuration file, and then it will use whatever we specify in the configuration file to compile the model with this particular optimizer. However, it's not as straightforward as just having a string for the optimizer. You can see that these optimizers will have different values such as the learning rate, the decay, the momentum, and so on and so forth. Okay, so for example, if we wanted to use SGD, right, and we want to also have these values as a configuration, then we sort of want to represent our optimizer as a configuration object, right? Okay, that configuration object will have a name. So for example, for SGD, okay, SGD will have a learning rate. Okay, so for example, if I want the learning rate to be 0.01, I'll have it right there. You'll have a decay, or if you want to use the default values, then that's okay as well, right? But in the meantime, I just want my software to support, let's say, learning rate and momentum. Okay, the value for momentum, let's just use the default 0.9, for example. Again, I can change these parameters as needed. Now, why do I want it to have an object? Well, object as a configuration, right? Well, for one reason is that some of the optimizers in Keras have different options that don't exist in other optimizers. For example, RMS prop will have epsilon, right? So we want the software to sort of check, like if the optimizer's name is SGD, then it's expected that the configuration will have these parameters to insert as part of the compilation of the model, right? If we have the name of the optimizer as RMS prop, then it still has learning rate, but it has other things as well, like RHO, okay, or epsilon, right? So it's expected that if we use RMS prop, then these parameters will exist in our configuration object, right? So again, we want to decouple the software, the code, from the actual configuration so that it would be easier to sort of use and replicate later on. Okay. For now, we'll use SGD. Okay, and to implement what I just said, that can be as simple as having an if statement and say that if the configuration for optimizer, okay, for optimizer's name is equal to SGD, okay, then what we do is we compile that, right? We compile our MLP model to have an optimizer of optimizers. Okay, so you just follow the one in the documentation, optimizers.sgd. Okay, optimizers SGD. Okay, where our learning rate, represented by LR, will come from self.config optimizer learning rate. Okay, so it sort of works as like an adapter class, right? You want to abstract the underlying Keras parameters called LR with your own standard, let's say, learning rate, right? Okay, so we have learning rate right there, LR. And we have, of course, momentum. Yep, momentum. Self.config optimizer momentum. Okay. Right. if the optimizer we use was SGD. Okay, let's take another optimizer, so we can practice on that whole configuration setup, right? So let's say for Adam, which is another popular way to sort of optimize your model. So we say else if, oops, you can see here that this one is the Ruby way of doing else if, but in Python it's your complete else if I'm not mistaken. Okay, else if your optimizer's name is equal to Adam, then it's expected, okay, to just copy paste this. Oops, okay. Then it's expected that well, you still have, I believe you still have learning rate. Okay, you don't have momentum. Okay, so scratch that out. But you still have learning rate. You also have something like epsilon or beta 1, beta 2, and so on and so forth, right? So you can add that here. Let's say you always want to require epsilon. So you say epsilon equals self.config optimizer epsilon, right? In the case of Adam, and you can extend this, have the software support have the software support more abstraction for the different Keras optimizers. Okay. Let me just double check else if, because I'm not confident how we actually use else if in Python. Okay, W3 schools, take a glance. Oh yeah, right. So you don't actually have else if in Python, but rather you have this thing called elif. Okay. Okay, so that's our sort of configuration for our optimizers. Okay, now maybe I'll stop there. I just want to verify if this thing actually works before we go to the training thing. And one way to do that is to actually call summary from Keras, right? So you have model.summary. So this one prints out how your configuration looks like, how your neural network looks like, right? Okay. Model.summary prints a summary representation of your model. Okay, so shortcut of utils print summary. Okay, so that should be a simple abstraction. Actually, it's very repetitive. Okay, so every time you call out a summary from our class, right, not Keras class, right, this one will just call MLP summary, right? I think that's self, something like that. Okay. Okay, so just as a review, so our constructor accepts the configuration file. We read it as a JSON read. We create our sequential model. We loop through our configuration of layers. If we're in the index 0, then we create a dense layer that has an input dimension argument so that it knows how to accept input with a certain dimensionality, which is configured in input dim in our JSON object. If we're not in the index in index 0 of our layers array, then we add a dense layer without the input dim. So that's practically the only difference, right? Our activation is customizable, so we can just change the activation value here, and we have a compile function that sort of overrides the compile function of Keras, or rather makes an abstraction for the compile function of Keras. But oh, I think we forgot to add metrics. I think something like metrics equals metrics, something like that. I think. Anyway, we'll still run and see if it works. All right. Okay, so we compile it. Depending on, okay, this one is not SGD, this one is Adam. All right. depending on our optimizer that we choose here and its corresponding configurations, we have an if-else statement to go through the name of the optimizer represented by this object. So if it's that particular name of the optimizer, then you're expected to have the following values. If it's the Adam optimizer, for example, then you're expected to have the following values for the corresponding compile arguments. Right? And then we have summary to sort of print out the summary for this model. Okay, so I guess I'll probably end with this, with having this function actually work. Okay. Okay, so right, so I constructed this and we'll just call summary, and it should print out the summary for this model. Okay. Hopefully this works. Okay. A module not found. No module named Keras. So I guess we haven't installed Keras yet. What's missing? Oh, right. So apparently in Python, we need a requirements.text. It's requirements.text. Yeah, I think we have to do something like this. Right, so we call pip install our requirements.text. How does the text file look like? Can't remember. All right, so we just put. Okay, so I guess we just put in the requirements here. So we need Keras. I don't know, JSON, I think. Right. And TensorFlow. I think something like this, right? And we should pip install our requirements.text. Excuse me. Oops, sorry. How do we run this again? Pip install our. Oh, we don't have JSON. I think it's part of. Okay, there we go. Whoops. Cannot find a version that satisfies the requirement. Our requirement. TensorFlow. How did I do it? Should have worked. That's weird. Wrong spelling? TensorFlow. Do you actually need TensorFlow? So Keras works. TensorFlow. Should have worked. I'm not sure why it didn't. Might need NumPy later on. So again, not too familiar with Python yet, so everything is sort of new to me, at least in terms of syntax and how we should actually construct a Python program. Should have worked. Sure, it did work. Yeah, so should have. Let's try that again. Why won't TensorFlow work? We need more stuff. Okay. At this point, I guess this one already works. Anyway, try to figure it out, but as far as we know, we only need Keras. Okay, let's try to run this again. No module named TensorFlow. Why won't TensorFlow work? We actually need to call pip3. I don't know, man. And call Python. That's weird. This is not what I... Huh. You have to use conda. You have to use conda. Yeah, yes. Okay, that's weird. Usually I just do pip install TensorFlow and it automatically works. It's very different now. I'm not too familiar with it. Okay, let's just wait for that to install. Maybe if I search Anaconda Python pip requirements TensorFlow, maybe something will come up. Should be as simple as pip install, right? I'm not sure why it's not reading from requirements.txt. Oh. What's this? So much for my my comeback. No module named TensorFlow. Okay, do away with requirements.txt. Should I do this? Okay, so unable to import TensorFlow is that Anaconda does not store the TensorFlow package in the same environment. What Python am I using? 3.7. I guess Python 3.7 is not supported. Oh, I see. Stick to that's so weird. Should be as easy as could not find. Did they name it TF? guessing here. That's not. That's not it. Wow, so I guess we have to backtrack to 3.6. Maybe, right? Maybe. Yeah, I think I have to backtrack to 3.6. How do we do that again? I think it's called deactivate. This version is still 3.7. All right, so we see. Okay, so let's try to. Sorry about that. Okay, so let's try to install a lower version of Python and see if it will work. Oh, what a failed video. Okay, this might take a while. Alright. Maybe we can implement a few more things. Okay, so you have a summary right there. I really want to change this for reserve the training part for a separate video. I really want to have requirements.text work. So Keras, something like that. I really need to dig up more on how Python works. I think they're all saying, like, if you're going to program in Python, make sure to use virtual env or Conda. I think Conda is the best for doing things like data science because it has like a lot of pre-built-in packages included, like pandas, NumPy, of course, as well as a whole slew of other things. So in this case, we're backtracking to Python 3.6 because I'm on Linux, and apparently, yeah, for Linux, you only have until 3.6 support, at least officially. I'm not sure why some of the forums say 3.7 is supported, but I guess we're down to 3.6. Hopefully that's the case, right? Okay, let's try this again. So let's check out our Python version. So we're now down to 3.6, and let's try to install our requirements.txt. So I guess it's working. Do you have TensorFlow? Okay. Already satisfied, so I guess we can now try to run our program. Okay, there you go. Now it's working. Alright, so a bunch of errors, and let's go and debug this before you call it a day. MLP line 8. Why? I'm not sure how to debug Python code yet. Expecting comma delimiter JSON decoder. So I guess I have an incorrect JSON file. But I guess it did read the configuration correctly. Oh, there it is. I'm missing a comma right there. Okay, let's try it again. Okay, alright, now we have our model printed out, right? input size 5, okay, output size 1. Okay, and just as a simple exercise, let's go ahead and change the configuration. Let's say we want to implement a sequential model that looks something like a deeper one, right? So for example, let's say this one, right? So our input is size 5. Our first hidden layer is 368. 368. So that's 5, 8, 8, 6, and then 4 for the output layer. So we're going to have something that looks like 5, 6, sorry, 5, 8, 8, 6, 4. Okay. So I want 8, 8, 6, and then 4. Okay. So we can have something like that. So you can see we changed the configuration just to take into account how our hidden layers are set up. Each of them will have their own activation function, so you can go crazy and say like, I want this to be sigmoid, and then the rest are relu. I don't think that will work as desired, but I can have a bunch of configurations to play around with, right? That way, if you want to play with a different configuration, you don't have to rewrite parts of your code. You just have to load up the configuration file, and that's how your neural network will look like. Okay, so I guess that's it for this video. I guess it's time to sign out from this video. Probably for the next one, I'll try to implement the train part, right? So we're actually gonna try to train the model using some sample data set, and then produce the output of the model in a model file that we specify, right, as part of our command line argument. Okay. Now before I leave, one last thing I have to do is to make this an official get repository. Okay, Python produces a bunch of things like this PyCache thing, so what I want to do is I want to ignore that. So I'll put in a git ignore, and I want to ignore everything in the PyCache. I'm not sure else what to ignore, so right, so I have to research on what other things we have to ignore whenever we run our Python program. I know it produces some other things as well. I keep forgetting what those things are. But right, so commit. Excuse me. Okay, first commit. Go ahead and create. Okay, one nice thing I liked about Microsoft's takeover of GitHub was that they actually, at this point of writing, right, they made private GitHub repositories free. Okay, so you don't have to pay like before, right? If you wanted a private repository in GitHub, you'll have to pay for it. Now you can actually click private, unlimited private repositories, which is very useful for small dev startups, right? That way, you don't have to sort of pay for private repositories, and unlimited users is always good. And that's one thing I liked about what Microsoft did with GitHub, because they actually made it under their watch. So this Keras implementation of in multilayer perceptron. Right. Just add something here. Usage. All right. Okay. Oh, we forgot to include it. Okay, create repository. Okay, so that's under rlmpy, kmlp. I should have a repository for maybe I should delete this because RLMPy is actually my personal GitHub page. Maybe I should have a repository for devlogs, right? Okay, I might change that in the future, but for now, add origin KMLP. Right. Push that there. Okay. Okay. So I guess that's the first video of 2019, and maybe I'll try one more tomorrow. Okay, so time to sign out. Stop